Hello everyone, welcome to the Bioinformatics tutorial 5. In this tutorial, I'll be talking about sequence alignment and multiple sequence alignment. Sequence alignment means we will align two or more sequences and we'll see the differences between those sequences. So, in the last tutorial, we revealed 5 FASTA sequences, and in today's tutorial, we'll be seeing the differences between those sequences. So the first sequence will be our query sequence, that means the sequence of EXA21, and other sequences like other 5 or 4 sequences will be the associated protein sequences, which can be used as a template for this protein. So let's see how this works. So to do the multiple sequence alignment or sequence alignment, there are many popular tools. Among those tools, we will be using 2 tools. One is Clustal Omega and another one is Praline. So let's go to those servers first. So to go to the Clustal Omega, so we will type Clustal Clustal OMEGA and then press enter. So you see Clustal Omega multiple sequence alignment. So we will be clicking here. So after clicking there, you see we are pasting our sequences, especially the amino acid sequences or FASTA sequences here. So here is written sequences. That means you have to paste at least 2 sequences here. First, we will paste the sequence for EXA21. So to get the sequence of EXA21, I'll be typing NCBI, and after typing NCBI, I'm typing here EXA21, then go search for this protein, and then we will be clicking here in the protein, and after clicking protein, we'll be clicking FASTA to get the amino acid sequence of EXA21. So remember one thing, that is whenever we are doing multiple sequence alignment, you have to give a header. That means you have to put a name on those particular proteins. So this is the amino acid sequence, say for an example. So I will be pasting this first, and then at the top of the sequence, like we will be pressing enter here, and at the top of the sequence I will be giving an identifier or a header for this protein, and there should be a bracket like this. So say for an example, this is the sequence for EXA21. We can do it another way, like we can delete the entire thing. So we can delete the entire thing and we can just copy and paste the entire thing here. So I'm copying it and pasting it here. So after pasting it, we will be pressing enter. And then let's take the sequence for FLS2. So I'm copying it and pasting it to Clustal Omega. Then I'm taking the sequence for GS01. So I'm copying it, the entire sequence, and then I'm pasting it here. And then let's take the sequence for another protein. So I'm copying it and then again pasting it here and then pressing enter. The sequence for BEPR1, I'm copying it and pasting it here, and finally the final sequence, that is the sequence of TDR. So I'm taking around 6 sequences in total. So now we will be submitting our job. So just press submit. So after pressing submit, it will take some time to do the alignment, and you see this is the result for the alignment, and you can see the result in colors. So I am pressing show colors. So after pressing the colors, you can see the aligned sequences here. So the region where all the amino acid aligns, it is giving a star mark. You see, it is giving a star mark, and then two dots, and then the less aligned regions are given by 1 dot. When we don't have any alignment, it is showing nothing, it's empty here. And whenever we don't have any kind of alignment with any particular sequences, like we have gap, then it is showing this gap thing, this hyphen like structure. We can develop a phylogenetic tree from these sequences, and let's see how this works. So I'm clicking here phylogenetic tree. So after clicking phylogenetic tree, it will be showing you the similarities or genetic diversity between these proteins. So you can see that the EXA21 is not that much similar with the other proteins, okay, but here you see the 5GR8 and 5JF1, these two are from the same node, That means the genetic diversity is very less for these two proteins, and the characteristics will be kind of same. So this one and this one is closely related, and then this two again is closely related with this one. Maximum genetic diversity is present between, say, EXA21 and some other proteins, because we see complete different nodes here. So this is the phylogenetic tree. We can get it from the Clustal Omega server. So now I will be using another server to show you the multiple sequence alignment. To do that, I'm opening a new tab and typing praline here. So I'm typing praline, and if you type only praline, it won't generate any result. So you must type praline multiple sequence alignment and then press enter. So you see IBI view server. So this is the praline server for multiple sequence alignment. So I'm clicking here. Just like the same way, you have to copy and paste your entire FASTA sequences here. So let's copy the sequence of EXA21 first in the praline, and then let's paste some other sequences, like say we are pasting the sequence for FLS2, and then we are pasting the sequence for GSO1, then paste the sequence for PEPR1 and press enter, and press the sequence for TDR, like this way. And just you have to run praline. One good thing about praline is it will generate a very excellent result. I mean, the picture is really beautiful, and you can see that you can generate a PDF file as well. And that PDF file is very much important for you if you want to publish any data or result, because the color profile of praline is really good and the quality of the picture will be really good. This is a basic difference between praline and Clustal Omega. And one more thing, that is, you see that Clustal Omega generated the results very quickly, but for praline it might take 10 to 20 minutes to generate the results. Even it could take higher. So if you paste many sequences, and if the sequences are very long, then it might take 1 hour at least. So we are waiting for the results of praline to come, and we'll see the results very soon. Remember, different multiple sequence alignment will generate different results. So you can see the alignment here like this way. The praline tool might not generate the same alignment, because different alignment tool has different algorithm. So if you take any one of those, it will be alright. So let's wait few more minutes for praline to generate the result of multiple sequence alignment. So now finally we have the result of praline sequence alignment. So they are giving an alignment score here. They're saying that the number of sequences are here 5, and the person sequence identity is 0.32, the alignment length and number of gaps. So let's see the results. So basically you can see the results like this way, based on the conserved region and unconserved region. Conserved region means that this portion, say for the red colored, these amino acids are same, like that we have seen in Clustal Omega as a star. It's also giving a star here, see. So it is also scoring the alignment results. Say lower score is given for the less similarity or less aligned region, and higher score is given for the highly aligned region. Also one more thing, that is, you see we don't have any alignment result for this particular area. So why is that? I'll be answering this question whenever I'll be doing the modeling. So you will see why we have this kind of gap within this part. So this is the result for praline, and you can make a PDF for this result. So if you click on make PDF, it will generate a very good result, and definitely you can download this PDF for your further use. So this is the result for praline. So you can see the hydrophobicity alignment or similarity between the amino acids by the server praline. Also you can see the secondary structure, okay. So where it will produce alpha helix, where it will produce beta sheet, where the structure will produce alpha helix and beta sheet, and so on. So you see helix are given red color and strands are given blue color here. So that's it for multiple sequence alignment. In the next tutorial, I'll be showing you some secondary structure analysis of protein. So till then, stay tuned and stay safe. Thank you so much everyone.